Hello, Assalamualaikum, and very good day to our lecturers. Today, we are from Group 4 and we are going to present about our project involving PLC and electrical power lab. Okay, next. This group consists of 3 members, which is the first one is me, KHAIRIAH binti Muhammad KHALID. The second one is Muhammad NAZHIIM bin SUBKI. And the third one is LISLEY Spencer LANA anak EBIE. Okay, next. Okay, there are 5 objectives for this project. The first one is students should be able to learn how to operate and program a PLC for a given application. The next one is students should be able to learn about different process description to control an automation system for various applications. The third one is students should be able to apply troubleshooting techniques and convert conventional relay logic to a PLC language. And the last one is students should be able to interpret PLC specification.
Okay, now we are going to the case study. For the first one is when the start button is pressed, the AC motor starts and remains on until the stop button is pressed for the door starter. And the second one is when the forward button is pressed, the AC motor begins to rotate in the forward direction. The motor will rotate in the opposite direction when the reverse button is pressed. The button will bring the motor to stop in either forward or reverse mode. The motor can be moved in either forward or reverse direction using an interlocking system. And the last one case study is the motor will start to rotate in forward direction after 5 seconds of pressing the forward button, and it will start to rotate in reverse direction after 3 seconds of pressing the reverse button. The stop button will bring the motor to stop in either forward or reverse mode. The motor can be moved in either forward or reverse direction using an interlocking system.
Okay, next, I will explain about the experimental setup without the PLC first. So as you can see here, we use the MCCB, 1 unit of MCCB, 1 unit of MCB. Then there are 3 contactors that we use. The first one is for direct online starter. The second one is for forward contactor, and the third one is for reverse. And we use 2 unit of thermal overload relay. And there is a few stop button, which is the first one. As you can see here, we use the first one is start push button for direct online starter. The second one is stop button for direct online starter. And we use 2 pilot lamps, which is the first one is for stop, and the second one is for start button, start light. Okay. The next one, we use 3 push button, which is the first one is for start which is the first one is for forward push button, the second one is for reverse push button, the third one is for stop push button. And on the other side, you can see we use 3 pilot lamps, which is the first one is for forward, the second one is for reverse, and the third one is for stop light. So as a summary, we use 5 unit of push button, and 5 unit of pilot lamps. That's all. Thank you.
Okay, now we are going to the experimental setup with PLC. The component that we use in this setup is 1 unit for MCCB, 1 unit for MCB, 3 unit for contactor, which is first is main contactor, second contactor forward, and the last one is contactor reverse. Now we also use CP1E E20 SDRA Omron CPU unit, and 3 unit for 8-pin relay MY2N, 24 VDC 8-pin relay MY2N. From the left is relay for door starter. The second one is forward, and the last one is reverse. Next is switching power supply, convert the AC to DC supply. Next one is we use two different switch, which is first is for push button for dual. From the top is start button and next is stop button. The indicator for dual is for from the top, the green indicator is for motor and the red indicator for trip. For the next set is for button for push button for forward and reverse. From top is forward button, reverse button, and the red button is stop button. The indicator for forward reverse from top is forward motor. The green indicator from top is for forward. The second green indicator is reverse, and the red indicator is for trip. The laptop is to display our ladder diagram. We also using two thermal overload relay. The first one is for dual starter, and the second one is forward reverse setup, and the last one is about three-phase induction motor. Now we are going to run the video simulation. First, we will turn on the three-phase on the MCB and turn on the forward button. After 5 seconds, the indicator will turn on. Okay, the reverse button can push until we push the stop button. Push the reverse button. After 3 seconds, the indicator will turn on. Okay, now we're going to on the MCCB for the motor circuit, for the main circuit. After 5 seconds, we push the forward button. The motor will turn on in forward mode. Okay, stop button and turn the motor in reverse button. After 3 seconds, the motor will start in reverse mode. That's all from us. Thank you.
Okay, for next part, which is discussion, uh, there are two question given. Number one is why we prefer control system, and the second one is challenges while constructing the system. Okay, with due to respect, I would like to put forward the point that following the completion of this project, we recommend a control system with the assistance of a PLC. This is because research has shown that PLC are more flexible and reliable. The second one is PLC use less wire because we do not use relay based on control system. The PLC use fewer wire than the conventional method. Okay, the third one is by simply rebuilding the ladder diagram, the simplify the problem solving process. Because the PLC is programmed using a CPU, it is very simple to upload and download the necessary logic. Furthermore, it has lower consumption cost. In other words, less expensive. PLC are intend to take the place of relay-based system. Purchasing PLC is a one-time investment that save money on problem solving, working hours, and maintenance. As a result, we prefer PLC control system over relay-based control system. Okay, the second one is challenge while constructing the system. Okay, while making this project, we have faced some problem. Among the problem we faced was while making the direct online starter or DOL motor control. We forgot to dismantle the control circuit connection that we construct on the previous lab on the board. This causes the programmable logic control or PLC to fail. After dismantle the control circuit connection that we use for the previous lab and connecting the input and output to the Omron PLC CP1E E20 SDR-A. Our DOL circuit was able to function properly and as it should be. Okay, and in addition, we also experienced some problem while installing the forward forward starter and reverse starter circuit. Among the problem we faced were more and or less the same as what happened on those circuit. We forgot to dismantle the control circuit connection we used for the previous lab where we did not use PLC. We also incorrectly install relay where we have installed it using the same method as we used for the previous lab. This causes the relay to not work. We should not need to connect the output from relay forward starter to relay reverse starter or output from relay reverse and to relay forward starter because all the programs should be executed in CX programmer. In addition, we also had a problem while the relay not working due to the negligence we did. We were forgot to connect the COM for each relay output. Finally, the problem we faced was we mistakenly connected the neutral for both circuit, for example, motor control, with PLC, where each is neutral for the circuit are separate. For motor control, its neutral will be connected to MCB, while neutral for PLC is connected to AC to DC power supply. This error has caused both circuit to fail and produce current spark. Okay, that's all for discussion. Next one is the conclusion. In this project, we were taught how to use CX programmer software to program, test, and diagnose PLC programming fall in addition to other technical challenges. Additionally, based on calculation and theory, we were able to conduct trial on various type of electrical machine starting, power system, component, and behavior. The capacity to use theoretical knowledge of industrial motor control, initiator, and electrical power system has been demonstrated by each group member. The capacity to use the theoretical knowledge of industrial motor control macam ulang. By each group member enabling them to work effectively both alone and as a team members or leader in resolving related issues. That's all from me. Thank you.